polar and non-polar molecules, whereas molecules may have one connectivity or they may have more than one bonds. Molecules in which they are associated with the dipole moment, yes, for the polarity the reference is dipole moment. As we know, dipole moment is indicated with the mu. Mu can be 0, mu can't be 0. There are two cases. If mu is equal to 0, these of all molecules are said to be non-polar molecules. Whereas mu not equal to 0, then these of all are said to be what? Polar molecules. So therefore, here polarity is reference. Dipole moment is reference for the polarity. That we can say that for polarity, what is reference? That is dipole moment is reference for the polarity. The more the dipole moment implies what? More the polarity associated with the molecule. The lesser the dipole moment implies what? Lesser the dipole moment associated with the molecule. Though the molecule is having polar bonds, it may become polar, it may not becomes polar. So therefore, mu total is reference. That mu total will becomes equal to, suppose if two polar bonds are there, mu total will becomes equal to mu1 square plus mu2 square plus 2 times of mu1 mu2 of cos theta will becomes equal to mu total. Suppose two polar bonds are there. The first polar bond related dipole moment is mu1. Second polar bond dipole moment is mu2. The vector addition of these two dipoles of the bonds becomes equal to 2 mu1 square plus mu2 square plus 2 mu1 mu2 cos theta will becomes equal to total dipole moment. This total dipole moment is reference. If this total dipole moment is 0, then that is said to be non-polar molecule. If this total dipole moment is not equal to 0, then it is having polarity dispersion of charges, hence it is said to be what? Polar molecule. In case of polyatomic molecules, to become polar, there should be two conditions. To become polar implies what? Mu t not 2 becomes equal to 0. It has to follow two conditions. First number is, it should have polar bonds. Bond is polar. The essential condition is bond should be polar. After just the bond is polar is not the complete thing to decide the molecule is polar. Second thing is, it should not associated with symmetry. That is, not associated with symmetry. If it is not associated with symmetry, if it is not having any kind of symmetry, then only it should have the polarity, that is total dipole moment will not becomes equal to 0. Molecule becomes what? Polar. Some of the examples of polar molecules here, sulfur dioxide. In sulfur dioxide, though there are two sulfur and the oxygen connectivities, it is having bent shape, it doesn't have any kind of symmetry, hence here it becomes what? Polar molecule. Similarly here ammonia is having N connected with the hydrogens, but it is having one lone pair. This lone pair also offers dipole moment in this direction. All nitrogen and the hydrogens related dipole moments are also present in one direction. Net dipole moment is enhances one with the other, hence it is a polar molecule. Here ortho-dichlorobenzene. In case of ortho-dichlorobenzene, two chlorine atoms, it is more electronegative, hence it is present in this direction. Total dipole moment not cancels with one another because they are not present in 180 degrees, hence it is polar. Similarly, if I go for meta-dichlorobenzene, this is meta-dichlorobenzene, the same situation, it is also polar. Similarly, 1,2-dichloromethane, I can go for all other varieties also. Suppose here methyl chloride. If I go for DCM, that is dichloromethane, here also not cancels. It is also example for the polar molecule. If I go for chloroform, CHCl3, it is also example for the polar molecule. Similarly, if I go for the hydrogen peroxide, this is hydrogen peroxide. Hydrogen peroxide is open book structure, hence it is also what? Dipole moment not cancels with one another, hence it is also polar in nature. Similarly, that is cis alkenes, and in case of cis alkenes, dipole moment not cancels, hence this will also becomes example for the polar molecule. Some more examples of the polar molecules, that is NF3. If I go for nitrogen trifluoride, here nitrogen and the fluorines connectivities are present like this. So therefore here direction is present. This is offering dipole moment in this direction. So therefore here net dipole moment might cancels, but it is having net dipole moment, hence it becomes optical, that is polar. Similarly, in case of H2S, sulfur is connected with the hydrogens in bent shape. This is also polar in nature. As we know everybody, IF5, iodine, that is 7 plus 5, 12, 12 by 2, 6. Hence it belongs to the category of AB5E1 category. AB5E1 implies what? Square pyramidal. Here fluorine is there, here fluorine is there, here fluorine is there, here fluorine is there, here lone pair is there. Unsymmetrical, hence it is also having dipole moment. As everybody knows, N2O is a bent structure containing system in which nitrogen is having, that is 3 electron bonds are present, whereas oxygen is having unpaired electron. We will write it as 3 electron bond for this. So therefore it is also having bent in shape. As being it is having bent in shape, it is also polar. Everybody knows ozone is also resonance hybrid of these structures. It is also having, otherwise we can write it as what? Bent shape, otherwise we can write like this. Here it is also having bent in shape, so therefore this is also polar. Whereas in this case, this dipole moment might, these two cancels with one another, but these two are present in different quantities in different directions, may enhances with one another, hence mu not equal to 0. HF dipole moment is present, only two atoms combination, HCl, water. Similarly in this case, dipole moment is present because this OH bond is bent in shape. This is bent, this is also bent, but this doesn't cancels with one another. This is present bent, this is present bent. These two bends can't be present in one direction. It can be present like this, it can be present like this, hence dipole moment may not cancels, hence it is having net dipole moment. Though this is a trans alkene system, here the remaining groups are different, hence these may cancels, but these two are existing and they offers a proper direction of vector addition, hence it is associated with some dipole moment. Dipole moment will not becomes equal to 0. This is an alene case. Alene, similarly, it is considered as carbon with 4 different valencies, like this HF, this is HF. They doesn't cancels with one another, hence it is also having net dipole moment. Mu is not at all found to be equal to 0. Now we will go for examples where mu will becomes equal to 0. Let us go for these cases. Benzene, whereas in benzene all carbon and the hydrogens are present in such a way that all are present in opposite directions. These two cancels with one another, these two cancels with one another, these two cancels with one another. Net dipole moment becomes equal to 0. This vector dipole occurs or works in opposite directions with one another, hence cancels, dipole moment will becomes equal to 0. Here also in case of trans 2-butene 0, this is a symmetrical system. These two's resultant is working in this direction. Magnitude wise this will be equal to this, hence cancels, dipole moment is 0. This vector addition results, dipole moment is equal to 0. These two and these two appears to be working in opposite directions with equal magnitude, hence silicon tetrafluoride, methane all becomes equal to 0. Carbon tetrachloride also same fate. Whereas if we go for the phosphorus pentafluoride, it is present in such a way that this is trigonal bipyramidal. This planar system cancels with one another, whereas the above the plane and the below the plane cancels with one another, hence dipole moment is 0. Xenon tetrafluoride is present as square planar geometry, therefore this is xenon. One lone pair is at the top, one lone pair is at the bottom. These fluorines are present on the square of the plane, hence cancels with one another, hence net dipole moment in the case of xenon tetrafluoride also becomes equal to 0. Here, 3 continuous multiple bonds are present connected with the similar atoms at the ends. It is similar to that of one bond between these, because every odd number of bonds will becomes equal to continuous odd number of bonds will similar to that of one bond system. So therefore, if it is this one bond system, dipole moment will becomes equal to 0. Sulfur trioxide is a planar system, so therefore here also dipole moment cancels with one another. In case of ICl4 minus, that is having square planar geometry with 2 lone pairs present at the top and bottom, it is square planar. As being it is square planar, then what happens? This particular vectors cancels with one another, top and bottom cancels with one another. So therefore in this case also this net dipole moment is found to be equal to 0. Thus polar molecules and non-polar molecules on behalf of vector sum of dipole moments, vector sum of bond dipoles, the net dipole moment, total dipole moment, and the examples of the molecules are like this.